The structure of an atom. Learning about the structure of an atom. Every substance is made of atoms. The atom of substance is ordinarily neutral. That is, it has no electric charge. This is because the number of positive electric charges and negative electric charges on an atom are equal. Many scientists have studied the structure, the atom, and advanced their theories about it. The theory proposed by Dalton, Thomson, and Rutherford are given below. Dalton's atomic theory. The English chemist John Dalton proposed the atomic theory in the year 1808. His theory is considered to be the fundamental theory about the composition of matter. He proposed that matter consists of very small particles, which he named atoms. An atom is hard, solid ball, and it is indivisible. Dalton's theory does not propose anything about the positive and negative charges on an atom. Hence, it was not able to explain many of the properties of substances. Thomson's theory. In 1897, G.J. Thomson, the British physicist, proposed a different theory. He compared an atom to a watermelon. A watermelon has a red edible part. In it, black seeds are embedded. Thomson's theory proposed that the atom has a positively charged part, like the red part of the watermelon, and in it are embedded, like the seeds, negatively charged particle which he called as electrons. To this theory, as the positive and negative charges are equal, the atom as a whole does not have any resultant charge. Thomson's great contribution was to prove by experimentation the existence of negatively charged particles, or electrons, in an atom. For this discovery, he was awarded the Nobel Prize in 1906. Although this theory explained why an atom is neutral, it was an incomplete theory in other ways. Rutherford's theory. Ernest Rutherford conducted an experiment. He bombarded a very thin layer of gold with positively charged alpha rays. He found that most of these rays, which travel at a great velocity, pass through the gold sheet without encountering any obstacles. A few rays, however, turn back from the sheet. Rutherford considered this remarkable. To understand this theory, let us carry out the following activity. Activity. Stand near a barbed wire fence and throw marbles towards the fence. A majority of this marble will pass right through the fence to the other side. but just a few of the marbles will hit the wire and be turned back. There is a lot of space between two wires of a fence. Hence, it is most likely that the marble will pass through. However, those that written point to the existence of the wires in between. Based on this experiment, Ernest Rutherford proposed his famous theory. In his opinion, the fact that most alpha particles pass through the goal sheet means that the atom consists mainly of empty space. The part from which the positively charged particles are turned back is positively charged, but very small in size as compared to the empty space. From these inferences, Rutherford presented this theory of the structure of atoms. For this theory, he was awarded a Nobel Prize for chemistry. Rutherford's theory proposes that the nucleus at the center of the atom has the positive charge. Most of the mass of the atom is concentrated in the nucleus. The negatively charged electrons revolve around the nucleus in specific orbits. In comparison with the size of the atom, the nucleus is very, very small. Protons, neutrons, and electrons are the fundamental particles in the structure of the atom. The particles in the nucleus of an atom are called as nucleons. They are of two types, protons and neutrons. Protons, that is, positive protons. The proton is the positively charged fundamental particle and it is located in the nucleus. Its positive charge is of the same magnitude as that the electron's negative charge. Neutron, that is N. This fundamental particle, N, is a nucleus. The neutron does not have any charge. Excepting hydrogen, the nuclei of all atoms contains neutrons. The mass of a neutron is approximately equal to that of proton. Electron, that is, negatively charged electron. This is a negatively charged particle and is denoted as negative electron. Negative electron is the fundamental unit of a negative charge. Electrons revolve around the nucleus of the atom in specific orbits. Electrons have specific energy depending upon the orbit in which they revolve. The mass of an electron is negligible as compared to that of a proton or neutron. Hence, the mass of an atom depends upon the number of protons and neutrons in nucleus. Generally, an atom is electrically neutral. The part of the atom outside the nucleus consists of negatively charged electron and a lot of empty space. The total negative charge of all electrons outside the nucleus is equal to the positive charge in the nucleus. That makes the atom electrically neutral. It cannot be said that atomic structure is the same as the structure of the solar system. The only similarity is that electrons revolve around the nucleus just as planets revolve around the sun. The planets of the solar system revolve around the sun due to gravitational forces. Now students, tell me, which force acts in the atom? The attraction force between the positively charged nuclears and the negatively charged electrons. Now tell me, what is the function of the neutrons in the nucleus? That is, the neutrons keep the protons, which have like positive charges, bound within the nucleus. Summary: electrons, protons, and neutrons are the fundamental particles in an atom. The protons and neutrons are in the nucleus of an atom. Electrons revolve around the nucleus of the atom. Protons have a positive charge. Electrons have a negative charge, while neutrons have no charge at all. So, dear students, that is all in this topic. Keep learning.